All right, so let's move on. Now we're coming to questions that you have to apply our multiplication to a problem. Okay, so in this problem, we have an equilateral triangle. So there's the equilateral triangle that's inside the square. So here's our square. Okay, so we have that picture. Now, what are we given? Well, we're given that the area of the square is 32. So we have some information to help us solve the problem. So we know the area of a square is that formula. A equals the side squared. All right, so if we can find this side of the square, all right, I'll make it green. If we can find this side right there of the square, we have a side of the triangle. Okay, so we know that the area is 32, so that takes the A spot. Now we're trying to find the side. So let's do some algebra. How do we get rid of a square? We square root. What we do on one side, we square root. So we know that the side is the square root of 32. Now 32 breaks down to 2 times 2 times 2 times 2 times 2 using that program. And we know it's a square root, so breaks out of jail. One group of 2, break out of jail, second group of 2, and this one's by itself. So 2 times 2 is 4, and the root 2. So we know all that work is to get a side, which is that. All right? Now, once we have the side, we can go answer the question. We're trying to find the perimeter. Well, the perimeter is the distance all the way around the triangle. Well, the triangle has 3 sides, so we know that there's 3 involved. And we know one side, that's for one side, is 4 root 2. So we apply our multiplication. 3 times 4 is 12, root 2. So we know that is the perimeter of that triangle. All right, now the second part of this question, we're trying to find the height, the exact height. Exact means no decimals. So we don't want to use our calculator and get decimals, no decimals. Okay, so what do we know from the previous question? Well, we knew that one side was 4 root 2. And we knew this side was 4 root 2 as well. But we're trying to find the height. We're trying to find that height right there. So we need to make it into a right triangle to apply our Pythagoras. A squared plus b squared equals c squared. So we need to take this length and take half of it. So you can see the little math there. This 2 divides into that to make it 2. So we know this half of that base is 2.2, or 2 root 2. Okay, now let's apply our Pythagoras. We know we have a C, because this is the C, it's the longest side, and this is the B, it's the base of the triangle. So we go in and we put the C in, we put the B in. All right, now when you square that number there, it gets you 16. And then when you square a square root, it disappears, so it becomes 2. So what it becomes is 16 times 2, which gets us 32. Okay, same thing over here. You square that to get 4, and that square root cancel each other out, so you're left with 2. 4 times 2 is 8. Now 32 take away 8 is 24, and 24 jailbreaks to 2, 2, and 6. All right? So now we get, well, it's 2, 2, 2, and 3. So we get these groups break out. So that's where you get 2, and 2 times 3 is 6. So there is the height. of that triangle. So now the last part is trying to find the area. That's the dark gray area of that triangle. So we know the area is base times height divided by 2. Well, we have all the parts. We just solve that. We know the base is that because we did that in the first part. We know the height is that because we did that in the second part. Now, let's apply it. 4 times 2 is 8. 2 times 6 is 12. Now, these guys can divide into each other because in radicals, the coefficient can divide into coefficients. Radicals cannot divide into coefficients. You cannot do this and make it root 6. That's a big no-no. Okay, so this 8 divided by 2 is 4, and you got root 12. And then root 12 breaks down to 2, 2, and 3. These guys break out. Times that by 2, and then you get 8 root 3. All right. So now let's try this one. So we have an isosceles triangle. So there's our isosceles triangle. Isosceles means two sides are equal to each other. The base of the triangle is root 20. The sides are 3 root 7. 3 root 7. Okay, the first thing I would do, I would simplify that just to make it into simpler terms. Because we know 20 breaks down to 2, 2, and 5. Jailbreak, that comes out, so it's 2, it's gone. So really this is 2 root 5. It's better than root 20. It's the simplified version. Okay, so we got our drawing. Now what is the question asking us? Well, it's asking us to find the area. Well, we just did that. Area is base times height divided by 2. Well, what do we have? Well, we have the base. The base is down there at the bottom, right there. That's the base. That's 2 root 5. We don't have the height, so we have to go find the height. And we know how to do the height. We draw a line down the middle. All right. We make it into a right angle because we're going to apply Pythagoras. So this is the height. So now we know that this whole length right here is 2 root 5. I want half of it. So I take the 2 root 5 and I divide it by 2. That cancels. So now I know that this part right here, this half, is just root 5. Okay? So now, root 5, let's do our Pythagoras. C squared take away B squared. So we have C, which is the side right here. It is 3 root 7 squared. Take away the bottom here, the base, which is root 5 squared. Okay, so let's just do some math. So we know that we square that first to get 9. And that 2 and that square root cancel each other, get 7. So 9 times 7 is 63. It's still in the radical. Subtract that, cancels that, so it's 5. So what does that equal? That equals 58. All right, so now 58, root 58 is our height. So all that work is to get our height of root 58. So now we can put that into here, root 58. Okay, now let's just apply our stuff we know. Now, remember there's a 1 there, so we times this by this to get 2 radicand times radicand to get 290, and then all over 2, and this picks that off. So our area is 290. So that's our our answer here. Now I'm just going to go back and show you something that is a common error up here in this little simplifying business. Now I've seen this happen where we're simplifying and you see a 2 there and you see a 2 there. I see this. You cancel them out. We call that in math cherry picking. If you take a 2 from here and a 2 from there, there has to be a 2 or something common in all those spots to simplify. If there's not, you cannot do anything. So don't just pick off. That's cherry picking.